Good afternoon, students. Hello, everyone. Good afternoon. Yes, good afternoon. How are you, students? Welcome, everybody. Welcome in today's class, everyone. So, students, in the last class, we have started our discussion on the limits, right? We have seen what is the limit, how to find the LHL, RHL, left-hand limit, right-hand limit, and if there is a greatest integer function or fractional x or modulus function, then we have to calculate the limit separately, right? Left hand limit separately, right hand limit separately. But if there is a function type of polynomial upon polynomial, trigonometry function upon trigonometric, then we don't need to find the LHL, RHL separately. We can just directly find the limit using the limit techniques. Okay. And we have seen how, so in today's class mainly be about how to find the limits. Okay, those limit techniques that I have talked about in the last class, we are going to discuss in today's class. Okay. Okay, so today's content is, first of all, we will see the fundamental properties to evaluate limits, then we will see the strategies to evaluate limit, and then we will see some important results in the limit. Okay, like in trigonometry, you have seen some formulae, right? That you need to remember to solve further good, or you can say some important questions, right? So in that, similarly, in limits, you have to remember some results, okay? So that for the complicated questions, you are able to solve it directly, okay? Clear, everyone? Okay, so let's start then. So first is the fundamental properties to evaluate limit, okay? That is, there are 5 rules. Okay, there are 5 rules. Let's say if limit x tends to c, f of x is capital L, and limit x tends to c, g of x is capital M, where L and M are finite values, means the limit of f of x at x is equal to c and limit of g of x at x is equal to c exist. Okay, that's why they are L and M are finite value. Then you can find the limit. First is the constant multiple rule, means if we have multiplied our function f of x with some constant k, then to find the limit at x is equal to c, it's simply nothing but k times L. Okay, or you can say that k can be taken outside and it is nothing but limit x tends to c, f of x only. Okay, and which is k into L, KL. Is this clear? Okay, if you multiply with some constant k, just take the k outside. Okay, second is sum rule. Sum rule means limit x tends to c, f of x plus g of x is nothing but limit x tends to c, f of x plus limit x tends to c, g of x. And remember, we are separating them because individually the limit is finite. Okay, this is nothing but L and this is nothing but M. So if it is finite, then you can directly separate the limits, okay, and find the limit of individual function and you will get the answer. Is this clear? Third is similarly the difference rule, that is limit x tend to c, f of x minus g of x में क्या हो जाएगा? L minus M, right? It can be given as limit x tends to c, f of x minus limit x tends to c, g of x. Okay, some rules remember these rules we are applying because the individual limit of a function at x is equal to c is finite. Okay, I will give you one example. From there you will get the idea. Okay, product is similar. If two functions are in multiplication, then you can directly write this as limit x tends to c, f of x multiply limit x tends to c, g of x, which is nothing but L into M. Clear, everyone? Clear so far? And similarly, if two functions are in division, are in ratios, then you can do it by the individually, that is limit x tends to c, f of x divided by limit x tends to c, g of x, right? And which is nothing but L by M. Is this clear? So these are the 5 fundamental properties in the limit to find the limits of any function. Is this clear? So if individual limits are finite, then there is some rule you can find the limit individually. Difference rule, product rule, quotient rule. Is this clear? Everyone, these 5 rules are clear or not? These are really important. Okay, you can say these are very fundamental things about the limits, because we will be using these 5 rules so many times in the questions. Okay, they will become the second nature. You will be using this 5 rule like unconsciously. Okay, like you won't be realizing that you are using these 5 rules while solving the question. So that easily, that second nature it becomes. Clear, everyone? I hope this is clear to you. Okay, so see, what I was saying is, let's suppose there is an example. Okay, let's suppose there is an example. Limit x tends to pi by 2. Okay, 10x minus sec x. Okay, tell me, can I write like this? Limit x tends to pi by 2, 10x minus limit x tends to pi by 2, sec x. Can I write it like this? Yes or no? Quickly let me know. No, right? We cannot write like this. Why? Because this limit is infinity. This is also infinity, right? Yes or no? So individual limits are not finite. We cannot write like this, like above, because individual limits are not finite. Is this clear, everyone? Is this clear? So we cannot like this. Okay. Hi JNV Balari. Hi Karthik. So guys, we have so far what I have discussed is, I have discussed these 5 fundamental rules. Okay. Constant rule, sum rule, difference rule, product rule, and quotient rule. Means if the limit x tends to c, f of x and g of x are finite, L and M, then if f of x plus g of x combined limit can be calculated separately. First find the limit of f of x. Okay. And then find the limit of g of x and add. Same with the difference rule, product and constant rule. Is this clear? Like if you have a complicated function, you can break that function in the small function and find the limit of the individual function and finally add, subtract, multiply or divide. Okay. Is this clear? But remember, these things you can do only when the individual limits are finite. So I have taken this example to show it. Sometime you won't be able to do it. Why? Because limit of the 10x at pi by 2 is infinity, limit of sec x at pi by 2 is infinity. So individual limits are not finite in this case, right? Yes, yes, Karthik. You have any doubt? You can write it in the chat box if you have any doubt. Okay, Karthik, if you have any doubt, you can okay, you can write it in the chat box. Okay, so individual limit has to be finite. Okay, if individual limits are finite, then you can use the fundamental rules. Okay, is this clear? Any doubt so far? Tell me quickly in the chat box if you have any doubt. Karthik, do you have any doubt? Please let me know in the chat box if you have any doubt, Karthik. All clear, students? Okay. If it is clear, then let's proceed further. Okay. Now we will see the strategies to evaluate limits. Okay. We will see the strategies to evaluate limits. Okay. So there are many techniques. First is rationalization. Sometimes what we will be doing is rationalization to see the whole point of the limit is that we want to there will be the indeterminate form happening all the time, right? So we want to get rid of that indeterminate form. So there are many techniques to get rid of those indeterminate form, right? So 7 indeterminate form we have seen in the last class, right? Is this clear? Yes, Karthik. Hello. Okay. So there are 7 indeterminate form. Yes. 1 second, students. I think 1 second. I think there is some mistake. 1 second, students. Just give me 1 minute. Okay. Yeah. Let me rejoin it again. Yes. Okay. As I was saying, students, so we have to get rid of those indeterminate forms. So how we can do that? One is the rationalization. Second is double rationalization. Third is the factorization. Sometime by using the factorization, we can get rid of those indeterminate form. And other various theorems on limits. We will be seeing the theorems on the limit also. Okay. And then finally, L'Hopital rule. Okay. So there are these so many techniques. Okay. So because of those, we can directly get rid of the indeterminate form and directly find the answer. Is that clear? So we will be seeing this method one by one. Okay. Don't worry about it. Okay. So let's start. So it's a very simple question. First is limit x tends to 1, x square minus 3x plus 2 upon x minus 1. Okay. So student, first of all, tell me, if you put x is equal to 1, so numerator will become 0 and denominator will become 0. So it is a 0 by 0 form, right? It is a 0 by 0 form. Clear? Is this clear? Okay. So it means this is an indeterminate form. So we have to find the limit, right? So how we can do this? So let's see. First is, tell me students, x square minus 3x plus 2 can be factorized, right? It can be written as x minus 1 into x minus 2. Yes or no? And denominator is x minus 1 as it is. So numerator and denominator say you can cancel out x minus 1, x minus 1. So what is left? You are left with limit x tends to 1, x minus 2. So now it is not the indeterminate form, right? We got rid of the indeterminate form. Yes or no? So directly put the x is equal to 1. What you will get? You will get minus 1 is the answer. Clear? So see how we solve the limit. We use the factorization, right? We use the factorization method to solve this limit. Yes or no? Is this clear? Okay, very good. And Amjad, very good. Okay, clear, right? So like this, we will be using the different method to solve the limits. Okay. Okay. Now if this is clear, let's move to the second question. Okay. I hope no one has any doubt in this question. Ye to काफी easy tha, right? It's very trivial question. So second question is this. Limit x tends to pi by 2, 1 minus sine cube x upon cos square x. Okay. First of all, yes. So can we do it with the u by v form? Okay. Karthik, okay. See, tell me, Karthik, u by v form means you are saying, so the Karthik is asking, students, Karthik is asking us that, sir, can we do it like this? So can we do it like limit x tends to 1, x square minus 3x plus 2 divided by limit x tends to 1, x minus 1, right? No, we cannot do it. We cannot write like this. Why? Because this limit is 0. The denominator mein you are creating 0, right? This limit is 0. And the fundamental theorem say you know that from the quotient rule, you can write like this, f of x upon g of x, as long as m, the limit of g of x is non-zero. But here the limit of g of x is 0. So that's why you cannot write like this. Is this clear, Karthik? Karthik, is this clear? Okay. Okay. So if it is clear, okay. So now let's move to the second question. Second question is limit x tends to pi by 2, 1 minus sine cube x upon cos square x. Okay. So first of all, tell me, student, at x equal to pi by 2, numerator is 1 minus sine pi by 2 ka cube, which is 0. Cos pi by 2 is 0. So again, it is a 0 by 0 form, indeterminate form. So we have to get rid of the indeterminate form. Yes or no? Right? So how you will do it? Let's see. Okay. So let's see how we will do it. So listen, Can I write it like this? Limit x tend to 5 by 2. 1 minus sine cube x upon cos square x can be written as 1 minus sine square x. Right? Clear? Now, what is this? Numerator देखो ध्यान से, numerator is written a cube minus b cube. And tell me what is a cube minus b cube, anyone? A cube minus b cube is? A cube minus b cube is a minus b into a square plus ab plus b square. Right? So this can be written as a minus b, 1 minus sin x into 1 plus sin x plus sin square x, and 1 minus sin square x can be written as 1 minus sin x into 1 plus sin x. 1 plus sin x. Clear? See, from the numerator and denominator, 1 minus sin x and 1 minus sin x is cancel out. Right? So now it is no longer in the indeterminate form, right? Numerator and denominator mein no 0 is getting, right? So now directly put the x is equal to pi by 2. So the quantity that was making our function indeterminate form, we have gotten the rid of it, right? 1 minus sin x is, we got the rid of it. So now put the x pi by 2. So directly you will tell the answer is 1 plus 1 plus 1 upon 1 plus 1. So which is 3 by 2 is the answer. Is this clear? So first get the rid of the indeterminate form. Then directly substitute the x is equal to pi by 2 or x is equal to a, whatever the limit we want to find at x. Okay. Is this clear, everyone? Any doubt so far? Tell me quickly in the chat box if you have any doubt so far. Clear? Students? Is there any doubt? Okay. So if it is clear, so shall we proceed further? Okay. So let's proceed further. So let's solve this question. Okay. Let's solve this question. So again, what is this question saying? Limit x tends to 0, x upon under root of 5 minus x minus under root of 5 plus x. Right? So first of all, at x is equal to 0, numerator is becoming 0 and denominator may put x is equal to 0, root 5 minus root 5, 0. So it is again a form of 0 by 0. Right? How we will get the rid of it? Let's see. So this is written as limit x tends to 0, x upon under root of 5 minus x minus under root of 5 plus x. Right? Rationalize it. Rationalize karte hain. So multiply with 5 minus x plus under root of 5 plus x in the numerator and denominator. Okay. We are rationalizing it. Clear? So under root of 5 minus x plus under root of 5 plus x. Clear? So what is this become? Limit x tends to 0, x into under root of 5 plus x, 5 minus x plus under root of 5 plus x. And in denominator, what you are seeing? A minus b into a plus b, which is a square minus b square. So 5 minus x minus of 5 minus 5 plus x. Clear? Is this clear? Okay. So in the denominator, 5 and 5 are cancel out. So what we are seeing? Minus x minus x. So minus 2x. Right? It can be written as limit x tends to 0, x into root 5 minus x plus root 5 plus x divided by minus 2x. So this x and this x cancel out. And now see the 1 upon, so minus half is a constant multiplied with the function, right? So we can take the minus half outside. Clear? From the fundamental theorem. So this is written as minus half limit x tends to 0, root 5 minus x plus root 5 plus x. Clear? Now it is no longer in the indeterminate form. Yes or no? It is no longer in the indeterminate form. We can directly substitute the x is equal to 0. So what you will get? Root 5 plus root 5. So what you will get? Minus root 5 is the answer. Is this clear? So see, we have used the rationalization technique here, right? Rationalization technique to solve the limit. Is this clear? Any doubt so far, students? Is this clear? Students, tell me quickly in the chat box. Is this clear? Okay. So if it is clear, shall we proceed further? Okay. So see, we have seen the factorization technique, rationalization technique, right? So we will be using the different technique, okay, to solve the answers. Okay. I hope this is clear to you. Okay. If it is clear, so let's proceed to the next question. Okay. Chalo. So students, I'm giving you 2 minutes, everyone. I'm giving you 2 minutes, solve this question and let me know the answer of this. Okay. Again, it is what form? This is the form of put x is equal to 1. So root 5 minus 1, which is 2, minus 2, which is 0 upon 0. So this is again 0 by 0 form, right? So I'm giving you 2 questions, 2 minutes, solve this question and let me know the answer. Everyone, let me know the answer. You have 2 minutes. You have 2 minutes, solve the question and let me know the answer. Yes, your time start now. Everyone solve it. So see how you can do this. You can check for the rationalization, right? Check, see how you can proceed with the question and let me know the approach in the chat box. Everyone, let me know how you are going to solve this question in the chat box. Please, everyone, let me know. Yes, everyone. Anybody got the answer? Anybody got the answer? Quickly, let me know in the chat box, everyone. What's the answer? Students, anyone so far? Okay, let's see then. So let's see first of all, okay, solution. So student, as you can see, it is a form of 0 by 0, right? So what we have to do? We have to get rid of the 0 by 0 form, right? Okay. So Karthik, what's the answer? Did you get the answer? Tell me in the chat box, Karthik. If you got the answer, tell me in the chat box. Okay, let's see then. So first of all, what you can do, obviously, you have to do the rationalization, right? So this is written limit x tend to 1, 5 minus x minus 2 divided by root of 2 minus x minus 1 multiply root of 2 minus x plus 1 divided by root of 2 minus x plus 1. So it is limit x tends to 1, limit x tends to 1, root 5 minus x minus 2, square root of 2 minus x plus 1, and in denominator what you are seeing, a minus b into a plus b, which is a square minus b square. So 2 minus x minus 1. Clear? So it is limit x tends to 1, root of 5 minus x minus 2, root of 2 minus x plus 1 divided by 1 minus x. Clear? So now if you check put x is equal to 1, numerator is becoming 0 and denominator is again becoming 0. So again we have 0 by 0 form here, right? So again we have to rationalize it. Is this clear? Is this clear? So what you can do is rationalize this root of 5 minus x minus 2. Clear? So you can say that it is written limit x tends to 1, root of 5 minus x minus 2 root of 2 minus x minus 1 divided by 1 minus x. Is this correct? Root of 5 minus x minus 2 upon 1 minus x, root of 2 minus x plus 1. Okay. So multiply and divide with square root of 5 minus x plus 2 divided by square root of 5 minus x plus 2. Clear? Okay. If it is clear, so what you will get? Limit x tends to 1. So root of 2 minus x plus 1 as it is. So this is a minus b into a plus b, which is a square minus b square. So what you will get? 5 minus x minus 4 divided by square root of 5 minus x plus 2 into 1 minus x. Clear? Is this clear? Okay. If it is clear, students, so what is this? 1 minus x, and here it is 1 minus x. So this and this cancel out. So now we no longer have 0 by 0 form, right? Now we no longer have 0 by 0. We got rid of the indeterminate form. So now directly put x is equal to 1 and get the answer. So what you will get? Root 2 minus 1 plus 1 divided by root 5 minus 1 plus 2. So this is 2 by 4, which is 1 by 2. So that is the answer. Clear? Is this clear? Is there anyone who have doubt? Tell me quickly in the chat box if you have any doubt in this question. Quickly let me know in the chat box. Clear, everyone? Right? So see, which technique did we use here? Double rationalization. Correct? 1 second, student. Just give me 1 minute. Just please, student, I think please rejoin it again. I think there is some issue. Okay, 1 second. Just students, just give me 1 minute, okay? Just give me 1 minute. Okay. Yes, I think this is clear now. Yeah. Karthik, please could you let me know, is my audio is clear or not? Clear, everyone? Okay. Okay, very good, very good. Okay, thank you. Yes. Okay. So let's start, okay? Let's start. So where was I? Yeah. So I was telling students, so here we have used the technique of double rationalization. Yes or no? Here we have used the double rationalization. Correct? Yes or no? So see, we have seen the different technique, right? We are seeing the double rationalizations and rationalization, factorization. So there are different ways we have to think of it, okay? And it will come with the practice. The more you practice, the more you will see the pattern there in the question that which technique is we are using, okay? So I hope no one has any doubt in this, okay? So let's proceed, okay? So let's solve next question, okay? Next question is limit x tends to infinity, x plus 3 upon 2x plus 5. So if you put x is equal to infinity in numerator, you will see infinity, and in denominator again infinity. So it is a infinity upon infinity form, right? It is a infinity upon infinity form. Okay. So one thing I am going to tell you. So please note that, students, whenever you see na infinity upon infinity, so try to create infinity in denominator. Okay. So whenever you see the infinity upon infinity, always try to create. What are you doing, Karthik? I think there is something happening in the screen, right? Karthik, I ask you not to do what. I think you are making something on the screen. 1 second. Okay. So try to create infinity in the denominator. Okay. So what I mean is, see, so whenever you have infinity upon infinity, always try to create infinity in denominator. Okay. So let's see. Solution is limit x tends to infinity. This is x plus 3 upon 2x plus 5, right? So the limit is on x, right? And x is going to infinity. So what do you do? Divide numerator and denominator with x. Okay, divide numerator and denominator with x. So what you will see? You will see that limit x tends to infinity. It is becoming 1 plus 3 upon x divided by 2 plus 5 upon x. Yes or no? Yes or no? Now, student, please look carefully. By dividing the numerator and denominator with x, we got rid of the indeterminate form, right? So no longer we have indeterminate form. Yes or no? If you put infinity in numerator, you will get 1 plus 0. If you put infinity in denominator, so you will get 2 plus 0. So we don't have any indeterminate form. So directly what you will see, it is nothing but 1 plus 0 divided by 2 plus 0. 1 by 2. Clear? Is this clear? Please let me know, reply in the chat box. So whenever it is an infinity upon infinity form, always try to create a infinity in the denominator. That's the best approach I can tell you. So there you can easily get the rid of the indeterminate form. Is this clear, everyone? Tell me in the chat box if you have any doubts. Clear? Okay. If it is clear, so shall we proceed further, students? Shall I proceed further? Okay. So now, if it is clear, let's try to create. Now let's move on to the next question. Okay. So again, what is this form? N is tending to infinity, right? So 3 raised to the power infinity plus 5 raised to the power infinity. So it is infinity plus infinity means infinity. Denominator also infinity. So again, we have infinity upon infinity form, right? So again, I'm giving you 2 minutes, everyone. It is very similar to the question that we did before. I'm giving you 2 minutes. Solve the question and let me know the answer quickly in the chat box. What is the answer, everyone? Let me know the answer in the chat box. I'm giving you 2 minutes, everyone. You have 2 minutes. Solve it and let me know the answer in the chat box, everyone. Yes. You have 2 minutes, everyone. Quickly reply in the chat box when you got the answer. Reply in the chat box, everyone. Everyone, quickly let me know the answer. Anybody got the answer? Anybody got the answer? Students? JNV Ballari, JNV Chitra Durga. Did you get the answer, everyone? Tell me quickly in the chat box. Reply. Okay. So let's see then. Okay. Everyone, please focus here. Everyone. See, again, I told you, right? Whenever you have infinity upon 1, okay, you are saying 1. So let's see. Okay, let's see if it is 1 or not. Okay. I think 1 is wrong answer, but let's see. So whenever you have infinity upon infinity, try to create infinity in the denominator, right? So what you can do is take 5 raised to the power n plus 1 common from the numerator. 4. Okay, let's see. Let's see JNV Chitra Durga. Okay. So let's take the 5 raised to the power n plus 1 common from the numerator. So what you will get? You will get 3 raised to the power n plus 1 divided by 5 raised to the power n plus 1 plus 1 divided by, again, take the 5 raised to the power n common in the denominator. So you will get 3 by 5 raised to the power n plus 1. Clear? So it is nothing but limit x tends, n here, in this case n. So n tends to infinity. So this is nothing but 5 raised to the power n plus 1 upon 5 raised to the power n. 5 into 3 upon 5 raised to the power n plus 1 divided by 3 upon 5 raised to the power n plus 1. So student, everyone, please tell me quickly, whenever you have na proper fraction raised to the power infinity, proper fraction raised to the power infinity tends to 0. Everybody knows that, right? Proper fraction raised to the power infinity tends to 0. So here we have the limit on n. So as you can see, 3 by 5 is a proper fraction. So proper fraction raised to the power infinity will tend towards 0. Clear? So what you will get the answer? You will get 5 into 0. Yes, very good, Janu Balari. Yes. 5 into 0 plus 1 divided by 0 plus 1. What is the answer? 5. So that is the answer. Is this clear? So always remember this, okay? If anybody don't know, now remember this, proper fraction raised to the power infinity tends towards 0. Okay? Is this clear? Tell me if you have any doubt in this. Clear? If it is clear, so let's proceed to the next segment. Okay? I hope no one has any doubt. If you have any doubt, you can ask me in the chat box. Okay? So let's proceed further. So now let's talk about the important result. Okay? So far we have seen some techniques, right? So we will be using those techniques in the upcoming classes. Okay? First we want to see the important results in the limits. Okay? Because what happens, I tell you students, what happens, limits, some questions some question comes very lengthy. Okay? And some questions are very short. So what happens, if you know some result directly, you can apply those results in the question to make it very easy. Okay. So that's why we are seeing some important results. Okay. We will be seeing 2-3 results today and continue tomorrow. Okay. So let's start. So first is limit x tends to a, limit x tends to a, x raised to the power n minus a raised to the power n divided by x minus a कितना होता है n times a raised to the power n plus 1. Clear? Clear? So that is the result. Okay, ये result है. Okay. So as you can see, what is this form? Put x is equal to a in the numerator. You will get a raised to the power n minus a raised to the power n 0. Put x is equal to a in denominator, a minus a 0. So 0 by 0 form. So remember this result. This result is very important. Limit x tends to a, x raised to the power n minus a raised to the power n divided by x minus a is n times a raised to the power n minus 1. Okay, the proof we will see. Okay, proof is very small. Okay, proof is very small. So before seeing the proof of it, I want to let you know one result. Okay, one more result. And that is nothing but a rule also. L'Hopital rule. Anybody heard of the L'Hopital rule? L'Hopital rule. Yes, this L'Hopital rule. So students, see, this is very, very, very powerful tool. Okay, because I guarantee you, most of the questions that comes in the mains now, you can directly able to solve those questions from the L'Hopital rule. And L'Hopital rule is super easy rule. Okay, I tell you what it is. So let's suppose f of x and g of x are differentiable function. Okay, f of x and g of x are differentiable function. Okay, and f of a is equal to 0. So value of f of x at x is equal to a is 0. Value of g of x at x is equal to a means g of a is also 0. Then if somebody asks you to find the limit x tends to a, f of x upon g of x, this can also be given as, you can differentiate the numerator and denominator directly. Okay, see, as you can see, this is 0 by 0 form, right? So differentiate numerator and denominator as long as you get the rid of the indeterminate form. Clear? Is this clear? Is this clear? So what I mean to say is this can also be further written as limit x tends to a f double dash x divided by g double dash x. Okay. So keep differentiating. So what does this mean? Keep differentiating numerator and denominator till we get rid of indeterminate form. We get rid of 0 by 0 form. Okay. This rule is mainly applicable for the 0 by 0 form. Okay. Okay. So whenever you see the 0 by 0 form in the limits, so directly you can apply the L'Hopital rule. Okay. Is this clear? So now I'll tell you the application of it. Okay. See here. Everybody please focus here. Now this is 0 by 0 form, right? X raised to the power n minus a raised to the power n. It is like a polynomial function, so which is always differentiable. X minus a again linear differentiable, right? Okay. So using L'Hopital rule, this can be written as the limit x tends to a x raised to the power n minus a raised to the power n divided by x minus a can be given as limit x tends to a. Differentiate the numerator. What is the differentiation of x raised to the power n? N times x raised to the power n minus 1. A raised to the power n is constant, so minus 0 divided by differentiation of x is 1, differentiation of a is 0. So what you are getting? N times x raised to the power n minus 1 upon 1. So we got rid of the 0 by 0 form, right? So now directly put the x is equal to a. So you will get n into a raised to the power n minus 1. So that is the result. Is this clear? So L'Hopital rule is very, very, very important. Okay, very important result. Okay, I hope this is clear to you. So what do you do when you have 0 by 0 form? Differentiate the numerator and denominator continuously. Okay, till we get the rid of the indeterminate form, and finally put the x is equal to a and get the answer. Is this clear? So L'Hopital rule is only for the 0 by 0 form, but we can extend the L'Hopital rule to apply in the infinity upon infinity form also. Okay. We can apply the L'Hopital rule in the infinity upon infinity. Why? I'll tell you the reason for it also. Everybody please focus here. Okay. See everyone. It is nothing but limit x tends to a f of x divided by g of x. Yes or no? So it is 0 by 0 form. Tell me, can I write this as limit x tends to a 1 upon g of x divided by 1 upon f of x? Can I write it like this or not? Again, it is nothing but in f of x upon g of x. But what happens is, as soon as you write it like 1 upon g of x upon 1 upon f of x, so now this is no longer in 0 by 0 form. Put x is equal to a. What you will get? 1 upon g of a. G of a is 0. So 1 upon 0, infinity upon infinity. Right? So L'Hopital rule you can apply for the infinity upon infinity and 0 upon 0. Okay? Because we can convert the 0 by 0 form into the infinity upon infinity form. So that's why the L'Hopital rule is applicable for both 0 by 0 and infinity upon infinity. Is this clear or not? Tell me quickly in the chat box. Is this clear? Students, is this clear? So it is very, very, very powerful tool. Remember, I'm telling you, most of the question, I can say the 50-60% of the time in the JEE mains or in any competitive exams, okay, the limit question mainly they give you 0 by 0 or infinity upon infinity, but the function is very lengthy. But you can directly differentiate the numerator and denominator separately, okay, and then just get rid of the indeterminate form and find the limit. Okay, is this clear? That's why L'Hopital rule is very, very, very powerful. Okay, We will see the application of this L'Hopital rule throughout this chapter. Okay. So many questions we are going to solve using the L'Hopital rule only. Is this clear? I hope I have made myself clear. Okay. Any doubt? Students, tell me quickly. JNV Belgavi, JNV Chitra Durga, JNV Ballari. Any doubt? Quickly let me know in the chat box if you have any doubt. Clear? Oh. If it is clear, then let's proceed further. Okay. So let's solve this question, everyone. Let's solve this question. Question is limit x tends to 0, 2 sin x minus sin 2x divided by x minus sin x. Right? Clear? So first of all, let's check the what type of form it is. Put x is equal to 0 in numerator, you will get 0. Put x is equal to 0 in denominator, you will get 0. So this is 0 by 0 form. Okay. So we can find the limit by directly using the L'Hopital rule, right? So using L'Hopital rule. So what this can be written as limit x tends to 0. So differentiate the numerator. Differentiation of numerator is differentiation of 2 sin x is 2 cos x. Differentiation of sin 2x is minus cos 2x into 2 divided by differentiation of 1 minus sin x. Differentiation of x minus sin x is 1 minus cos x. Clear? Now check. Put x is equal to 0 now. You will get 2 minus 2 means 0. In the numerator, we are getting 0. Denominator is 1 minus cos 0 means 1 minus 1, 0. So again, after first multiplication, again we have 0 by 0 form, right? So what does this mean? It means we have to differentiate again, right? So now again differentiate. What you will get? Differentiate the numerator. So using L'Hopital rule again. So this means it can be written as limit x tends to 0. Differentiation of 2 cos x is minus 2 sin x. Differentiation of this is minus 2 as it is. Cos 2x ka differentiation is minus sin 2x into 2. Right? Divided by differentiation of 1 is 0. Differentiation of cos x is minus sin x. And 1 minus is outside. So sin x. Right? So what you are getting? We are getting limit x tends to 0 minus 2 sin x plus 4 sin 2x divided by sin x. Right? Now again check, students. Please again check. Put x is equal to 0 in numerator. You are getting 0 and denominator also getting 0. So again we have 0 by 0 form. So it means differentiate again. So apply L'Hopital rule again. So what you will get? Limit x tends to 0. Differentiation of sin x is cos x. So minus 2 cos x plus differentiation of sin 2x. 4 into cos 2x into 2 divided by differentiation of sin x is cos x. So now check. Put x is equal to 0. We no longer have indeterminate form, right? So now we got rid of the indeterminate form. So what does this mean? It means we can now directly put x is equal to 0 to find the limit. So what you will get? Minus 2 into 1 plus 8 into 1 divided by 1. So what we are getting? Minus 2 plus 8 means 6. So that is the answer. Clear? Is this clear? Tell me quickly in the chat box. Is this clear? So see, just see, and the differentiation is not so hard also, right? So just by we did differentiation 3 times. So after the third difference, on the third differentiation, what happens is we got rid of the indeterminate form. So now directly substitute the limit and get the answer. Is this clear? Students, any doubt so far? Tell me. Okay, very good, Janvi Ballari. Very good. Okay. So if it is clear, so let's proceed again. Now the second important result is limit x tends to 0, sin x upon x is 1. Okay. and limit x tends to 0, tan x upon x is 1. So proof, again you can do it using the L'Hopital rule also. Okay. So proof के लिए use L'Hopital rule. So it is written as limit x tends to 0, tan x का sin x differentiation is cos x, because sin x upon x at x is equal to 0 is 0 by 0 form, right? And differentiation of x is 1. So now we got rid of the indeterminate form. So directly it is cos 0, which is 1. Clear? Is this clear? So first, but not that in the limit of sin x, this limit of x tends to 0, sin x upon x. So this x, this is in, it is in radian. It is in radian. Clear? It is in radian. That you should remember. Okay. Is this clear? Similarly, limit x tends to 0, tan x upon x is 1. Again, these angles are in radian. These angles are in radian. Clear? This is very important result, okay? Because most of the students forgot. Sometime in the question they give you in the degree. So first you have to convert that degree in the radian, okay? And then proceed with the question. Clear? Is this clear or not? Okay. If it is clear, then let's proceed further. So three important results we have seen so far, right? First one is limit x tends to a. So the first one kya tha? Limit x tends to a, x raised to the power n minus a raised to the power n divided by x minus a. कितना होता है? N times a raised to the power n minus 1. Second is limit x tends to a, sin x upon x is limit x tends to 0, sin x upon x is 1. Third is limit x tends to 0, tan x upon x is 1. Remember, this is sin x upon x where x is tending to 0. So you can say that limit, so you can say that limit of sin elephant upon elephant, where elephant is tending to 0 is always 1. By the mean of elephant, I means any complicated function inside of sine which at x is equal to 0 is tending towards 0. Okay. Any elephant, this elephant, when elephant tending to 0 will always give 1. Okay. Sine of elephant upon elephant where elephant is tending to 0 is give you 1. Is this clear? So it's just not for the x, any complicated function. Am I clear? Am I clear or not? Okay. If it is clear, let's proceed further. For example, let's say f of x at x is equal to a is 0, means f of a is 0. So if somebody asks you, find the limit of limit x tending to a sine of f of x upon f of x. So what does this mean? It is x tending to a sine of elephant upon elephant, where at x tending to a, elephant is becoming 0. So it is nothing but 1. Clear? Is this clear? Because this is again creating 0 by 0 situation. Is this clear or not? Tell me quickly now in the chat box. Clear? Okay. I hope this is clear to you. So don't get confused with that x. Okay. Sine of elephant upon elephant, where elephant is tending to 0 is give you 1. Straight and simple. I hope this is clear. Okay. So if it is clear, then let's solve this question. Okay. I am going to solve this question, student, using the two methods. One is the L'Hopital rule. Another one is the important results. So first, just we will use the important result. Okay. Method 1. So tell me, this is nothing but limit x tends to 0. Can I write it like this? Sine 3x upon sine 4x. So first multiply with the 3x and divide with the 3x. Okay. Divide with the 3x and again multiply with the 4x, divide with the 4x. Okay, that's what I'm doing. So what does this mean? It means it is written nothing as limit x tends to 0 sine 3x upon 3x divided by sine 4x upon 4x into 3 by 4. Clear? So this can be written as 3 by 4 into. Now we can separate the limits, right? Because limit x tends to 0 sine 4x upon 4x is not 0. Okay. So this can be written as limit x tends to 0 sine 3x upon 3x divided by limit x tends to 0 sine 4x upon 4x. How much is this? 3 by 4 into, this is limit x tends to 0 sine 3x upon 3x. See, 3x is tending towards 0. Sine elephant upon elephant and elephant is tending towards 0, right? So we'll give you 1 and same with here 1. Clear? So the limit is 3 by 4. So that is your answer. Is this clear? Is this clear or not? Tell me quickly in the chat box. Is this clear, students? Any doubts so far? Clear, right? So whenever we have this type of question, sine of 3x, sine 4x, sine of fx, try to create one more fx, okay? So that we have sine of fx upon fx. Because we know sine of elephant upon elephant, when elephant tending towards 0 will give us straight G1. Okay. Now let's see this. Let's solve this same question with the different method using the Alopetal rule. Method 2, limit x tends to 0 sine 3x upon sine 4x. See how quickly we can get the answer using the Alopetal rule. So using Alopetal rule, we can get is limit x tends to 0. Again, this is a 0 by 0 form, right? So if it is 0 by 0 form, so differentiate numerator separately, denominator separately. So differentiation of sine 3x is cos 3x into 3. Differentiation of sine 4x is cos 4x into 4. So now no longer we have the indeterminate form, right? So now it is nothing but put x is equal to 0. So we will get 1 into 3 upon 1 into 4. So 3 by 4 is the answer again. See, both answers are same, right? Clear? So this much powerful the Alopetal tool is, okay? That's why Alopetal rule is very, very, very powerful tool. Okay, because so many questions can be done in 1 or 2 lines just using the Alopetal rule. Clear? Is this clear? Any doubts so far, students? Please let me know in the chat box if you have any doubts so far. Clear? Okay. If it is clear, so I'm giving you this as a homework question, okay? This is your homework. This question is your homework. And yes, and this is also your homework, okay? This is also your homework. Clear? Please practice these questions, okay? These are very, very easy questions. And this one, homework. Okay, these 6 questions you have to solve it in your homework. Okay, these are very easy questions, okay? Please solve it, attempt it. We will be discussing this question in the next class. Okay, so that's all for today, everyone. Thank you, everyone. Take care. We will see you in the next class, okay? Bye, everyone. Take care. If you have any doubt, ask me, okay? Straight ahead, ask me. Otherwise, you can leave the class, okay? Bye, everyone. Take care. Bye, everyone.